All right. Good morning and good evening to you guys. How is everybody doing? I hope everyone is doing great. And let's get started. Just quickly, before we keep going, my plan for the rest of the session is maybe another two sessions, meaning today and Wednesday. Um, we are towards the close of the session. I'm planning to do all the concepts that are pending today and see how time permits start with SQL a little bit. And by the next session, probably on Wednesday, we must be done with this. You guys are free to go. All right. Um, with that said, let's get going. Let me share my screen here. Tell me when you can see my screen. All right. Okay. Okay. Um, all right. So just a quick recap on where we closed off last session. We talked about types of joins, right? We talked about inner join and outer join, and within outer join we talked about three types. Okay, left outer, right outer, and full outer join. Yes. While we do the joins, I just want to close with a small additional note on joins. There's something called a Cartesian join. Excuse me. See, generally, if you remember that the term join means you're trying to join on two or more tables based on a condition. You supply a condition and then say check the condition on these two tables or more than two tables. Each condition will run on two tables. Okay, so for example, if you see here, I said table 1 dot column 1 is equal to table 2 dot column 2. So between table 1 and table 2, I wanted to compare these two columns. And then if those match, I want to get the records. All right. Usually for any join, there is a condition. And when the condition is matched, it fetches the records from those two tables and it gives you a display on your editor, whatever editor you use. We call it an editor to put the SQL in, right? Um, what is Cartesian join? Cartesian join is basically you're joining two tables without a where condition, without a condition. You're not giving any condition. You're simply saying join these two tables. What it does like X cross Y on the tables, meaning if you have one table here and the other table here, it gives me a combination of all records of the first table and all records on the second table. Um, it does a cross multiplication, meaning for each record on the first table, it does a combination on all records of the second table. Then goes back. So basically, this is what happens. So R and S are two tables. It takes the first table R. The first record is A1. It goes to the second table. It fits A1 and the first record A1 gives me that combination. Again, for the same first record of table R, it goes to the second record, gives me that combination. So it gives me A1 and C2. Same way for the first record A1, it goes to the third record until it exhausts the second table. Then again, it goes to the second record, does the same thing. So basically, this is called a cross join. It's more like, your matrix multiplication. You are multiplying every record of the first table with every other record of the second table or all records of the second table. Make sense? There may be questions, this is practically not used anywhere. Remember me. All your joins will have a condition. Okay, a lot of times it's an inner join is what is used. Very rare to use outer join, but in practical scenarios, it's always inner join. Okay. Um, there may be questions in the exam. That's the reason why I want to touch on this. What is a Cartesian product? A Cartesian product works on two or more tables without a where condition. So basically, it gives all possible combinations. Okay. That's the one note I wanted to give on Cartesian join. I think with that, I want to skip out of joins. So we covered joins. Um, there's a lot of theory behind. So we're going to go slowly into SQL. I'm going to do data warehousing and data mining today. Once I talk about data warehousing, data mining today, We're going to skip into SQL. So basically, we talked about the software development lifecycle. We talked about design, analysis, and design. We talked about build. So we are slowly transforming. So we talked about how you read through a scenario, convert to an ER diagram, and then after you read an ER diagram, um, you kind of converted that to a table. So we talked about how to convert an ER diagram into a table. And the next thing is about how do you put data into the table? Assuming you created the tables, how do you put data into the table and how do you retrieve data from the table? So with that, your RDBMS for this portion of the syllabus is done. Okay, for your syllabus, but it's not just the end of DBMS. Okay, there are a lot many things within DBMS. Okay, so for the SQL to happen, there is a relational algebra behind it. Okay, it's more of a theory that explains anything that you use in your set theory, like union, intersection. You guys go through all those in math, right? So same theory is applied behind deriving SQLs. So I'm not going to talk about all those. I'm going to let you guys to just browse through. It's not really very from my point of view, it's not really very important. You're not going to use it practically anywhere. And from a theory point of view also, it's not very important, neither from the exam point of view. But you can just read through quickly if you want to. I'm going to leave this portion to you. This is the only thing that I'm leaving it to you guys, the relational algebra, the relation between relational algebra to SQL. How, the SQL is derived from relational algebra. Okay. All right. With that being said, let's get going into data warehousing. Let's talk about data warehousing a little bit. Data warehousing. What's data warehousing? Have you guys heard of this term anywhere, anytime? Data warehousing. Any idea of what is data warehouse? I've always said that. Remember my tip. If you don't know the definition of something, always read it reverse. So data warehouse is nothing but a warehouse of data, right? As simple as that. It's a warehouse of data. Yes, somebody responded. It's a place to store data. Yes. If it's a place to store data, thanks, Gavin. So if it's a place to store data, then what is database? What's table? You know, I don't know. You guys have not asked me a question. We kept repeatedly using the term table and database. Are they both same? Is table and database, is table the database? If you tell me yes, the answer is not yes. Okay. A table is a smallest form of the database. So a lot of tables together, you know, are stored in a table space, and then they go into storage space, things like that. We're not going to go into that detail today. But a collection of tables is what I would call a database. Okay. So data warehouse, similar to database, but it's a warehouse. Okay. What's a warehouse? A warehouse is where the goods are stored in layman terms. For example, we talked about Big Bazaar the other day. Okay, Big Bazaar sells a lot of items, but Big Bazaar doesn't store all the items within itself. It has a limited, storage at the back. So what it does, it might have a big data warehouse. I mean, not a data warehouse. It might have a big warehouse. It all the products from the manufacturers are shipped to the warehouse, and it keeps it in the warehouse. As and when the items are sold, it brings it to the showroom. Yes. So before it brings the products to the showroom, it puts it in the warehouse. That's warehouse, right? Same with retail. Any company, any store that sells products on large scale, they cannot store everything directly from the manufacturer into the store. So they have something called a warehouse. The items are shipped to the warehouse. As and when we keep selling things, as they exhaust, they keep loading it into the store. It makes sense. So same way, data warehouse is big collection of data. Okay, it's a bigger database. Let's say it's a very bigger database. Okay, all right. So why are we talking towards data warehouse today? Okay, so if I could jump into my notes here, this is what I want to crisp use it as a crisp here for you guys. If you have to write about data warehouse, there may be I know you have 2 mark, 5 mark questions about explain data warehouse, some applications of data warehouse. So it's basically a central repository. Repository meaning a storage of electronically stored data. It's a central repository. The moment I use the term repository means it's a big place. Okay, it's a central storage place. So data warehouse is basically a central repository of electronically stored data. So what happens is this: as we store data in our tables or database, when we back up, we want to back up when we want to back up the data from the tables. Like for example, I explained in certain places, the client doesn't want to store data more than 7 years, so they want to move the data to somewhere else. So when they want to do a backup, um, they move the data out of the database into a large storage. Okay, let's say that's a data warehouse for now until we finish the discussion. Okay, so the primary intent of the data warehouse is analysis and reporting. Okay, so what happens is this. Let's take an example. Amazon sells a lot of products, right? But Amazon is interested to know the trend. There is something called a trend. Okay, it cannot just keep selling the product. For example, Amazon might go to Punjab and sell some products. Some of the products might sell very well. Some of the products might not sell very well. For example, if it's trying to sell blades or scissors, where a product which is not primarily used by the people, then you're not making your sales there. Yes. If you go to Chennai, for example, Chennai is very hot. You go to Chennai and start selling um, heaters. You know, people are not going to buy it. It's already boiling there. People don't buy heaters. Right? You go to Kashmir and try to selling AC. People are not going to buy that. So you cannot just keep selling your products. You also need to know where to sell, where to market your product, which product to market where. Make sense? So that comes out only from an analysis. So you take your product, you're selling the product, and then end of the month or end of the sometime, you're doing an analysis to see how is my product behaving? How is my sales doing? If this particular product sells very well in this place, that means there is a demand for it. If this particular product doesn't sell very well in this place, then I should not be selling it. I should not be spending my time. I should not be setting up a store. I should not be shipping products to that place if nobody's going to buy that product in that place. Make sense? This is basically called an analysis. Okay, you come up with a plan. Okay, yes, thanks for the term strategy. Yes, you come up with a strategy to say, okay, where to sell what. Right? This is a simple example. Same way in any place. For example, insurance companies. You're selling insurance. These days you have a lot of different products in the market. People try to sell you a lot of different products. So before they start doing the business, they need to have the idea behind where to sell what. Yes, so that comes from analysis. The analysis comes from the data that you have. So the data that you just store in your tables is not enough, because you might want to do an analysis of the last 1 week, 1 year, 10 years. Okay, so you need to move the data from your table back to somewhere else, back to some other storage, and that is basically what I call data warehouse. Make sense? Why can't I just still store it in the tables and do it? Because the data keeps growing and growing and growing. Assume you keep the data for 10 years, and then after 10 years, the table is so big, your the time that it takes to access the table is very time consuming. Yes, it's going to be very laborious to maintain the data and to read it from it. So to avoid that purpose, we're going to do that. So we're going to start moving the data to data warehouse and then store it. Okay, sorry guys, so I need to move this. Okay, so now reading through all of our items. So what it also happens, I want you to underline this term heterogeneous. Okay, heterogeneous means it's an opposite of homogeneous, right? Heterogeneous meaning the source, the data is coming from different sources, not just from one table. It could come from tables, it could come from files, it could come from flat file, it could come from random access files, whatnot. So from different sources, okay? The data comes from different sources for the data warehouse. So data warehouse helps in business decision making. So for example, I said when Amazon finds out, okay, this particular product is not sold in this place, I may not be selling it here. Or if this particular product has a very high demand in this place, let me start selling it here. So that kind of a decision making happens from a lot of analysis from your data warehousing. Okay. DBMS is designed for transaction processing, whereas data warehousing is for analysis and reporting, right? That's what we've been talking about. So that's where I explained. Database will store day-to-day data. Anything transactional means an unit of work. You find, for example, you withdraw money from a bank, okay, from an ATM. From the start, from the time you put in your card, ATM card into the ATM until you withdraw your money and take the ATM card out, that's one transaction. Okay, you go book a ticket in airlines. From the time you log into the system, into the website, you start the process, you finish booking your tickets, and then if you guys have questions, feel free to speak up. So from the time you finish, from the time you start booking your tickets until you finish booking your tickets, take a printout of your ticket, that's one transaction. Okay, so DBMS will basically store transactional data, anything that happens day to day. Whereas data warehousing is for analysis and reporting. Why reporting? Because a lot of times people will ask, like for example, I go to my team and say, can you give me a report of something? So they should be able to pull the data and give it to me, right? So database is application specific, data warehouse is organization specific. So I want you to guys understand this term. Database is an application specific. Application specific means, let's say you go work for a client. Let's assume it's a retail client. Okay, the client will have different applications: a sales application, a revenue application, a finance application, products application. There'll be different databases for each of them, right? All the products that they sell, they might maintain a separate database for it. All the sales that they might maintain a separate database for it. So these are application specific, whereas data warehouse is organization specific. You will have a one single data warehouse for the whole organization. Okay, that is where all the data is dumped. So just imagine it's going to be very huge. DBMS is, again, we call it operational database, meaning it stores the current data. Data warehouse is decision support database, which means it stores historical data. Okay, makes sense? These are some of the keywords. Not all of these will be in your textbook. I just pulled out from my various different sources. Um, so basically, this was one of my specialization when I studied when I did my master's. I studied about data mining, expert systems, decision support systems. These are some of my areas of interest. Okay, these are very interesting. You will not know how applying some logic will help you to derive at some conclusion. So basically, when you start reading, for example, we did our ER diagram. Our ER diagram we made from just a context that was given, right? We went through the context. We ended up creating a picture. Same way, when you start your expert systems or decision support systems or data mining, you will not realize applying certain rules on a theory will help you make some decision. Okay. For example, you're thinking about, should I buy a car? If I want to buy a van or a car, what kind of car should I buy? I will be asking you a few questions. If you answer me yes or no questions, I will be able to derive to a conclusion and say, look, based on all your answers, this is what you should be doing. If you remember, a lot of surveys, a lot of surveys are done. You guys might have taken some online surveys. The reason why the surveys are done, based on your answers, people are trying to understand your trend or your interest. Based on that, they'll give you recommendations. So far, so good. So I want you to go through these and understand some of the key points. So if you have questions, based on the question, the weightage of the question, if it's a 2 mark, you don't need to write everything. If it's a 3 mark, if it's a 5 mark. So you take a call depending on the weightage of the question, and then you write on that. Okay. Now quickly, let's talk about how the data flows in data warehouse. Okay. I know it's going to be a little bit dry. So if you're not very paying attention, just wake up a little bit. Next 5-10 minutes, I'm going to talk some theory, and then we'll get out to the SQL. All right. So this is what happens. These first two things you'll not see in your textbook. The first two things are not in the textbook. So I just want to use and bring it to you understand. So CTS stands for, I'm using the term CTS for current transactional store, meaning it's a database that stores all my data. Today, let's go with a banking or a retail application. Okay, let's take the example of BigBazaar. So CTS basically stands for current transactional store. It stores all the transactions that I do today. So any customer walks into the bank, walks into the store, buys a product, there is a transaction that happens, they capture the data. So there is a person. So if these days everybody becomes a elite customer or rewards program. So you have a member ID, and then you give your membership card. They know who is doing this transaction. They have all your data, your address, phone number, name, etc., etc. And then they do the transactions. They, whatever products you buy, they kind of charge you. They give you a bill receipt. You pay the money. You're done. So that particular data is captured in the current transactional stores. Okay. Now what happens after periodic time, after a week or so, your current transactional database becomes big. So what they do backup. They do a backup after some periodic time. It depends on the size of your transactional store. So it could be weekly, it could be very rarely people do it daily, no. But once a week, once a month, once a year, they back up the data from CDS into ODS. Make sense? ODS stands for Operational Data Store. Okay. Sometimes it's called operational system. So on a periodic basis, you're backing up the data from your daily tables or database into an operational data store. So far we are only talking about data store. Now comes the terms of data warehouse. So this is where the stages of data warehousing starts. So how does the data flow through, or what are the evolution of, you can use the term evolution of data warehousing. So first thing is called the first stage of data warehouse is called offline operational database. There is an offline database. Still, I have not used the term data warehouse, but there's an offline operational database. What it means is, so there's one other point I forgot to mention here. So anytime you do your, anytime you do your transaction goes into here, excuse me, I said CDS. And I said on a periodic basis, the data is backed up. On a periodic basis, the data is backed up. On a weekly basis, whatever it is. And then let's assume somebody goes back into the store and says, look, I bought this product about 2 months back, and then this product is faulty. I want to return it back. For example, you bought a microwave oven, or you bought let's say you bought any machines, okay, a refrigerator, a washer, whatever it is. So you go back and say there is a fault in this machine. So you need to pull out your transaction to really check who bought this product, what date, etc., etc. They go into the CTS, they don't find your data because the data is basically moved to ODS because they are backing up every week, let's say. You're coming up after 2 months. So all your data stays in ODS. So what happens, it tries to fetch in CTS. If the data is not found, it goes back into ODS, fetches the data. So fetching the data from ODS is going to be a little bit time consuming because it is not that frequent. Yes. So it has to go through a process to fetch the data. Well and good. So now what happens after after certain time from your operational data store, the data is offloaded into an offline operational database. This is the first stage of a data warehouse. They're taking all the data here and dump it here so that some analysis can start. So people can start looking at the data. This is more like unorganized data here. It's not organized, it's not refined, nothing. It's just some dump of data, okay, from your ODS. Now what happens from your offline database, then comes your offline data warehouse. So it's even more a bigger data warehouse. So again, periodically, this is done like, again in certain periods. From your offline database, it's dumped into your offline data warehouse. So these are the two places people start working on. Your backend data engineers, data scientists, and if I could use the term data scientist, we have started using these terms these days. Data scientists. The data scientists start using, the data scientists start moving, start analyzing the data. So they just move the data into they work out of offline data warehouse. And sorry guys, I got diverted. Somebody's trying to reach out to me. So offline operational database and offline data warehouse. This is where the data scientists start to work on. Okay, they try to find a lot of information. They try to find a lot of patterns. They kind of start doing some reporting out of it. Now, so far it is all offline. Okay, it's not online and nothing is connected to the network. Now comes your real-time data warehouse. So what happens in a real-time data warehouse with the with the introduction of the internet, so now what happens, your data warehouse is connected to internet, meaning people can access this data warehouse because it comes online. Yes. So what happens when this real-time data warehouse is built, the data could be directly offloaded from your ODS, the operational system, directly into your real-time data warehouse. Make sense? Now this is where if you go into internet, start searching for something, for example, you're trying to understand what are the courses that you can do, um, what are the types of engineering that you have, immediately on your Facebook page, you will see advertisements for engineering colleges, advertisements for products related to what you searched for. Yes, how? Because anything that you browsed has quickly gone into real-time data warehouse. Okay, and I will introduce one more term now. It's called an integrated data warehouse. So from different sources, anything that you are doing is loaded into integrated data warehouse through internet, and that is helping them, all the companies, to quickly feed data back into the transaction. I know it's a little dry, I just want you to follow along with me, but if you have questions, feel free to stop me. Anybody has questions? Okay, so continuing on. So from your offline data warehouse, I talked about real-time data warehouse. Okay, so with the introduction of internet, all the data is directly download from our ODS, okay, operational data store, into real-time data warehouse whenever there is an event or transaction that happens. So more like it stores the data into your CTS as well as into data warehouse. Immediately it's feeding data into this. Anytime an event or a transaction happens. What is an event or transaction? For example, I said when you withdraw money from a bank or when you book an airline ticket, that's an event. So the moment you book a ticket, for example, you're booking a ticket from, like I said, from Bangalore to Chicago. The moment you book a ticket, it's a transaction. The data is fed into your real-time data warehouse. So what happens is that your real-time data warehouse will now start working on the background. Okay. So the data comes here, people can try analyzing your data to see, okay, you know, somebody's trying to book a ticket, um, where is he located, what's his interest, they start analyzing this. Now what happens, the data goes into something called integrated data warehouse. What is this integrated data warehouse does is this, it looks at, okay, MarieDass is trying to is trying to book a ticket. He has just booked a ticket from Bangalore to Chicago, so that means let's throw him some items around Chicago. So it will start giving me some suggestions around places to stay in Chicago, places to visit in Chicago, things like that. So how does that happen? That immediately feeds back. So from the integrated data warehouse, that quickly starts analyzing the data for me. Okay, it analyzes my data. Okay, he has booked a ticket from where to where. Where is he living now? Where is he going? What is his interest? Did I give a reason for my booking? So maybe while booking the tickets, I might have said my interest is because I'm traveling for business purpose. Then it starts giving me all business related recommendations. Where can I stay for business purpose? When people travel on business purpose, what all do they do? If I said no, it's a family trip, it starts giving me suggestions about the family trip, right? So that is all because the integrated data warehouse analyzes the data here and feeds quickly back into my operational data store. That means instantly somebody knows what is my interest. Somebody sitting, for example, let's go back to a retail store. Somebody sitting in front of the counter and selling you products, assume that the moment you're staying in front of the counter, somebody is trying to market something based on your interest. It may look at some data. Okay, in the past, X person came, he came and bought this product, and today he's buying product two, and today he's buying another product. So from the integrated data warehouse, it does a lot of analysis and understands your trend and your interest. And quickly it's feeding back the information to the person sitting in front of the computer, selling you the product. So that person can talk to you and say, are you interested in this product? Right? He's trying to market you. So they try to understand your interest that comes from data warehouse. The data warehouse will do a lot of decision making, and it gives you a lot of historical data from the past and try to give or market products to the current world. Make sense? Is it too dry? I know the terminologies may be dry, but if you look at the theory, it's as simple as if you have to go sell a product somewhere, you'll always use your thought process, right? Where can I go sell this product? It's more in marketing, is very much used. Where can I go sell this? I cannot go sell this in a place that people will not buy. You have to go sell it in a place where people buy. So how do you know where people buy this? That is where the data comes from, data warehouse. Make sense so far? Any questions, concerns? I just want to take a quick pause here to understand if you guys have any questions. Otherwise, I want to talk about data mining. They're both related to each other. Are you guys with me so far? All right, I'll take that as yes. I didn't see any chat note, so I take that as yes. Okay, so I quickly want to run through the advantages. So advantages of data warehouse. Okay, very good. Two people confirmed. Go ahead and go over them. Thank you. So advantages of data warehouse. So data warehouse helps the end user with reporting and analysis. So in this case, the end user is basically not the customer. It's the because it's for the organization, right? So it's basically for the data scientist. The data scientist knows how to report and analyze the data. It increases the business productivity. That's what we've been talking about, right? Productivity. You know where to sell your products now. And again, you can maintain data from heterogeneous sources in one place. Like I said, from tables, from database, you can store all the data in one place called data warehouse. So if you want some data, you know where to go for. Now, what are the disadvantages? It's time consuming to extract, clean, and load the data into data warehouse. When we talk about data warehouse, there's a process called ETL process, extract, transform, and load. Okay, anybody who talks about data warehousing will always talk about this term called ETL, extract, transform, and load. So they extract the data from the transactions that happened. They clean the data. Not every data goes into the database, right? Some of the data they may not be interested. They may be interested in my age, but not my date of birth, right? The age because they're trying to understand what age category is buying this product, but they're not interested to know what is my date of birth exactly, right? So they'll clean the data. They'll not take every single information from the table. So they clean the data and then load it into data warehouse. This is a big process, right? Because different sources will be in different format. If you are sending data from tables and files into data warehouse, it cannot be just dumped there, right? You have to clean up the data from the file has to be formulated or transformed into a way that can go into data warehouse. The data coming from a flat file or a notepad has to be cleaned up in a different way. The data that's coming from a VZM file has to go in a different way. The data that's coming from tables have to go in a different way. So from different sources you have data, they have to be cleaned up and then loaded into data warehouse. Because data warehouse will take data in only one format. So that is very time consuming. Number two, data can be outdated so quickly. That is true, right? I mean, you're storing data about some product today, but within a month or so, within 2 months, within 5 months, the data is outdated, meaning that that product is no more in the market. For example, all our mobile phones, they're all manufactured. They say to work only well for 1 year, maximum 2 years. Right after 2 years, you will see all sorts of problems coming in your mobile phone, right? Irrespective of any brand you buy, right? So your data gets outdated. So you might have data on your data warehouse that is of no use now, okay? And then training the end users to use data warehouse may be a little difficult. So if I'm a new person that I'm starting to use data warehouse, it is difficult for me to understand what is all this data, okay? And security could be an issue because the real-time database or data warehouse and your integrated data warehouse are on the internet. Anything on the internet is always risk prone, right? I always say this. Every advantages, every advantage comes with a disadvantage at least, right? Everything on the internet is easy to access. Yes, click of a button, centralized data. Sitting anywhere in the world, anywhere in the universe, I can get the data, yes, but it is always risk prone, right? So security is an aspect if it is connected to internet. And maintenance is expensive. This is very important. A lot of times people don't go for data warehousing concept. It's called EDW. EDW stands for Enterprise Data Warehouse. All big organizations have it. Mid-sized organizations think about should I go to data warehouse or not because the cost to maintain data warehouse is expensive. So it's always called a win-win situation. The benefit that I get by investing is not big, so I don't want to go into it. If there is no big benefit, I don't go for it. All right, good. So some of the advantages and disadvantages. There may be questions about what are the advantages and disadvantages of data warehousing. All right, let's move to data mining. We got another minute to disconnect, I think. So if you guys get disconnected, join back on the same link and we'll talk. So data mining is nothing but it's very closely related to what we have already talked about. Now this was again another um, my major or specialization in my master's. So when I did my master's degree, I didn't even know what is data mining. Okay, so it's very interesting to know you apply certain algorithm and then derive at some decisions. So this is an example here. If you look, and somebody is planning to buy a car, they don't know, should I buy a car? Should I buy a van? Within a car, what kind of car should I buy? So now basically the decision tree is derived from your data warehouse. You're mining your data, you're picking up certain data. So now it's asking me a question, is the person over 30 years? Then you say yes. And then the next question is the person married? Yes. Again, there may be another question. Let's say, is the person having children? Yes. Then the recommendation would be the person, it's best to buy a minivan for the person because how is this decision arrived? Let me start my recordings here. So welcome back, guys. And so we're talking about data mining. Okay. Um, so that's where, let me pull up my example here. All right. So this is an example here. So we talked about how was this decision made. So basically by asking of certain questions, the system is able to give me a recommendation of what is best for me. So I'm in a little bit of confusion. Should I buy a minivan or a sports car or a different sedan, whatever it is? So now I go to the system and answer a few questions. Are you over 30 years? I say no. Then it says, okay, then it's best for you to go for a sports car. You know, how is this decision made? This called a decision tree. What you're seeing here is called a decision tree. This decision is made by asking a few yes or no questions to you. Yes. How are these questions formed? It's basically formed based on backtracking your data in the data warehouse. So you looked at the data in the data warehouse, and then you said many people who were over 30 years old and who are married, who have children, always bought a minivan. People who are not over 30 years or who are like youngsters always bought a sports car majority of the time. So you don't need to spend your time to do this analysis. A lot of times, you know, when you have to buy a big thing, you know, you always have a question, right? For example, when I want to buy my car, I always have so many choices and options in front of me. Should I buy V6? Should I buy V8? You know, what should I buy a minivan? Should I go for a car? Should I go for a sedan? Should I go for a convertible? What not? I have so many options in today's world, right? Especially with the internet, you just go type and then you got 1,000 options in front of me. The time it takes to compare all the pros and cons, advantages, disadvantages, you'll end up losing your interest in buying car, right? So the system makes it easy for you. It asks you a few questions and then gives you an answer. Um, okay, so that's basically what is data mining. So data mining basically helps you in picking up a certain pattern from the data warehousing data. Make sense? In simple terms, it identifies a certain pattern. The pattern here is most of the people over 30 years who are married, who have children, bought minivan. That's a pattern. So it identifies a pattern in the data and then it kind of comes up with a decision tree. That's called data mining. Make sense? What does it help me? It helps customers with decision making. It could be data scientists, it could be end users. It helps with decision making. So let's quickly look at, am I sharing my screen or not? Oops, oopsie doopsie. Yeah, okay, so I want to go back. Let's open up your textbook quickly here. Okay, so, all right, so let's look quickly at what your textbook has to talk about data mining. All right, so we talked about data warehousing, we talked about the pros and cons. Okay, I'll come to it in a quick second. So we talked about all these. Okay, so we're talking about data mining, it identifies the trend. So it just quickly talks about the different stages. First thing is selection, then it does a pre-processing. So we talked about all this. Then you transform the data, and then you report out the data, interpretation and evaluation. Okay, so I think that's a very broad touch upon data mining. Okay, dokie. So with that, it marks the end of the first chapter. I know it's pretty long, but it's more theoretical, conceptual. But each of this is going to help you um, in your future. Okay, as you go down in your path, and let's assume you guys end up being in the field of database, data mining, data warehouse. There are different kinds of work. I know people working in EDW, data warehousing, people working in different fields of data scientist, data analysis. So we'll talk more on that when we close the session tomorrow. Okay, so let's quickly jump into SQL. So when I talk about SQL, I'm not going to spend too much time. The reason because it's very appropriate to talk about SQL having an editor open here. It's called an editor. We usually call an SQL editor. Some kind of an editor to open and see. I want to show you how the tables are created, how the data is fed into the table, how the data is retrieved from the table, how it's changed, manipulated, etc., etc. But unfortunately, I cannot do that here. I do have DB2 or I do have databases on my machine which I cannot share here. I do not have a DB2 or database that I can share on this place. So I think speaking with Madhavi madam, I understood you will have some SQL hands-on sessions soon when you get back to your colleges. So I'm going to recommend I'll browse through some of these quickly, give you a very overall idea of what is SQL, what are the different types that we have, and then when you get into your colleges back in the laboratories or your computer science labs, you can spend a couple of sessions practicing some of these SQL. That is where you'll completely understand how to create table or to put data into. Make sense? So let's touch upon very high level what's SQL. If you remember, one of the CORDS rules says the database should be talked to only through a powerful language. That's one of the CORDS rule. Remember, CORDS rule is one of the CORDS rules says there must be a powerful language to talk to the database, and one of them is the SQL, or it is the SQL. Irrespective of whatever database you should use an SQL. Whether you use MyAccess, DB2, Oracle, you should speak to the database through an SQL. Okay, SQL stands for Structured Query Language. Okay, Structured Query Language. So it's kind of a language, people say, but it's not a programming language. It's called a query language. Okay, so a language which is used for querying but is structured in nature. If you use my technique, read it reverse. What's SQL? SQL stands for Structured Query Language. It's basically a language used for querying databases which is structured in nature. Why is it called structured? Because it has a syntax. You have to follow the syntax. If you don't follow the structure, if you don't follow the syntax, it throws you an error. It doesn't do the data. It doesn't do the job that you want it to do. Okay. So broadly, very broadly, SQL can be grouped into these 5 categories. Some of them talk only 3, 4, or I would say there are 5 broad categories. DDL stands for Data Definition Language. What is data definition? Meaning you're defining the data. Define means you're defining the structure. That's a logical structure. You're defining how your table should look like. My table should have 10 columns. This is the name of the table. This is the primary key. This is the foreign key. Things like that. You're defining the table. That's why it's called data definition language. Make sense? There are multiple commands in a data definition language. For example, these are some of it. Create, alter, and drop. Create will help you create a table. Excuse me, guys. Create will help me to create table. Alter will help me to alter the structure of the table. Meaning, I created a table with 10 columns. Today I want to add one more column. I can do that, use my alter command. I created a table whose size is 10 characters. Today I feel I need to change it to 11 character. I do that using alter. So here, understand, I'm not changing the data. I'm changing the logical structure of my table. Yes, that is why it's called data definition language. Drop stands for dropping the table or deleting the table. I'll be using the term delete in a short while, but that delete and these are not same. Drop stands for dropping the whole table. The moment you drop a table, it's completely deleted. The table and its data are completely deleted. You can't use the table until you create it back again. Okay, so far so good. Why is it called data definition? Because it defines the structure of my data or my logical data or my table. What are the commands used in DDL? These are the commands. Next, moving on, DML stands for data manipulation language. What do you mean by manipulation? Changing. Okay, we call it manipulation. You change the data. The term manipulation is misleading. It has been constantly used in a place of illegal update, but it's not. We are not manipulating illegally. Okay, we are only modifying the data. Manipulation stands for um, modifying. Okay, DML, data manipulation language, talks about some of these commands. Will do that. Insert, update, delete are some of it. What is insert means? I'm inserting. So after I create my table, I'm inserting data into the table. So insert command will help me insert data into the table. Update. Update command is basically I inserted a record and then I feel, okay, somebody's address has changed. Today you are in Bangalore, tomorrow you're in, let's say, Boston. I need to update your address. Okay. So I need to update the address. I use an update command. Delete. For example, for some reason, this record needs to be deleted from the table. Okay, this person has left the organization. You need to delete the data, let's say. Use a delete command. Remember, all of these commands are acting on the data, not on the table. It's data level updates, yes? Inserting a data, updating a cell, updating a row or a column of the row or one cell of the table, right? Deleting one complete record. Make sense? That's DML, data manipulation language. Data control. It's called data control because it controls the data access. I should use the term data access. Why is it called a control language? Because these commands control the data. What it means is, for example, in the current world scenarios, the database administrators might create the table for you, okay? But it will be given to you. Let's say, for example, you end up to be a developer. So the database administrators will create the table and give it to the developers to put data into it because they don't know the data. So they give it to the data science or the data developers to feed data into the table. So the developer will write a query to insert into the table. Now the problem here is this: whoever creates the table is called the owner of the table. He only will have access to the table. Now, if a different person wants to put data in the table, he needs to be granted access to the table. Make sense? So that is done using the grant command. The grant command will grant access for a table or on a table for a resource. Revoke, meaning, okay, you're done with doing all your work. I don't want to give you that access anymore. I want to take that access back. This usually happens when I go to a project, I work on a project, they grant an access to me for those tables, and then after some time, they revoke access back from me because I move out of the project to a different project. They don't, security is an aspect. They don't want to give me access to the table. So they take the access back from me. So this is all called data control, right? This again on controlling the access. So that's why it's called data control. Make sense so far? This, you may not hear the term. I just used it because your textbook was using this term. DQL, it's very rarely used. Q stands for query, data query language. You're basically querying the table to do a select. So after you put the data into the table, you want to select the data from the table, use a select command. This is a very frequently used command. Select, select, and select. A lot of times you'll be selecting data from your table. Make sense? Um, so now the syntax for all of these are in your table. I'll run through some of it tomorrow in the next session. For now, I'm just using the terminology, but then tomorrow, I'm not going to deep dive, lose interest. I don't want you guys to lose interest because it's more like I'm going to talk about, what's a car, what features a car has. I keep explaining, let's say some high-end cars, and I keep explaining, what, Tesla has this feature, BMW has this feature. But if you don't even know what a car is, if I talk so much, you will lose your interest, right? So, I know already we are kind of remote. I'm sitting in a different place. I don't see any of your faces. At least you guys are lucky you see my face on the screen here. So I don't know how you guys look. I don't know anything, but still I'm talking. So already we are kind of in a remote setup. And if I go so much deep into writing queries without even knowing what's an SQL, what's an editor, how do you write your query, where do you write, how do you run your query, how do you see your results, you're going to lose your interest. So I'm not going to do that. So let's see, when you get back to your colleges soon, you're going to run these queries. And at that point of time, if you feel there is a need for me to talk to you, I can always do that. Okay. I don't mind coming back for a day and talking to you guys about how to run your queries, what are the different types of queries, and explain lots of tips and tricks behind each query. Okay. It's very powerful. Query is very powerful, believe me. All right, and the last one is about transaction control. This is not in your textbook. I just added for you to know. Transaction control language, TCL. There are two commands called commit and rollback. So quickly on what is commit and rollback. You guys know this. Commit stands for saving the work. Rollback means go back to a previous save point. Okay. So let's assume you are booking an airline's ticket on the internet. You started off, you logged in, you registered for the account, or you logged into your account. You're booking an airline ticket. Um, Halfway through, let's assume you're almost done. You went in, you're comparing prices, and you know what ticket you want, what seat you want, what date, etc., etc. And at some point of time, for some reason, either the browser crashed, or there was a power cut, or there was some interruption, and then you lost that page. So you're out of that page. So now you don't know what happened, because you started your transaction, you came halfway through, you probably submitted payment. You said, payment, click pay using my credit card, or PayPal, pay using my PayPal, like whatever. Let's say you use your credit card. You gave all your information about credit card and said submit, and it's kind of connecting to the transaction gateway. It's kind of talking to your bank and trying to get the amount from the bank, and that's when this has happened. So now you are in a soup. Now you don't know whether the money is taken. Do I get my uh, you know airline's ticket? you know so you're just trying to understand what to do next. You don't know what to do, and you'll be even more frustrated, or freaked out when you see that the money is withdrawn from your bank. Okay. And then you don't see your airline's ticket sent to you. You're like, what happened? Where is my airline's ticket? Let's assume this has happened. You call the airlines company, and they say, no, we see that the transaction was initiated, but the money is taken, but we don't see any clue of your ticket. We don't see that in your database. So you're freaked out too much, right? So if that is the kind of setup, we don't want that, right? So in this case, what ideally we expect is, because my transaction is not completely committed, meaning I did not go all the way, the ideal situation should have been, you are able to make the payment. After the payment is done, it says successfully you made the payment, and then it says this is your confirmation number, and then it gives you some kind of a reference, and then you get a ticket on your email or something, and then you're able to see your ticket online, and then you get a PNR number and says, okay, now I got my tickets. So that is basically a logical unit of work, or a complete transaction. You started and you ended with your ticket. So you have a confirmation that the ticket is booked. This is called one LUW, or logical unit of work. You completed a logical unit of work. Yes, a complete transaction. So what happens at the end of it is, basically at the end of the transaction, when everything is done, payment is done, ticket is booked, a commit is issued on the database. Commit is basically a save. Like when you're typing something on WordPad and you say Control S, I just go and say save here, right? Just say file save. That is basically what is a commit. You're performing a commit. Once you save, the changes are made permanent on the table, okay? Unless you perform a delete or something. Rollback is basically, what happens is, when the transaction is interrupted halfway through. Okay, when the transaction is interrupted halfway through, you expect that it goes back to the previous state. A lot of times, when you're working on something, your word crashes, you will not see the previous data, right? Sometimes it has an auto save, but sometimes it says you didn't save anything that you performed between last save and before it crashed. So when you're doing the same airline booking, at some point of time when there is an interruption, the system recognizes we did not reach to a commit point. We did not reach to a save point. So let me go back to the previous save point. What was the previous save point? Maybe you created an account that and then saved your data. So it will go back and then the database will go back to a state where as if you did not even start the transaction, as if you did not even start booking your ticket. So going back from the current state to the previous committed point or save point is called rollback. Make sense? People who know this may be boring, but people who are new to this term, commit and rollback, I want you to understand. This is very, very important. So when you're working on a database world, you need to know where to issue a commit because you may be using at least a 100 application program, and each of your application program may be talking to a different table to fetch different data. You may be performing the last program, the 100th program, may be performing some join operations and then feeding the data into another table and saving it. If you don't use a periodic commit or use a technique to periodically commit your data, you're going to lose your data if, if for some reason the transaction crashes. If you don't want that to happen, you got to be giving periodic commit points so that you know even if the transaction breaks or interrupts, some of the data is committed at some point and you know where to initiate the transaction again. Okay, a lot of times in practical world this happens. Okay, we receive a data from somebody else, we receive the data into our system. Okay, and then the data that's received into our system, we start processing it, and then down the line somewhere our transaction is interrupted for some reason. Okay, if I don't periodically commit, I'm losing the data that somebody else sent it to me. Now, I'm doing a business with my customer. I cannot go back and say, look, yesterday there was a power cut in my organization, or some reason I lost all your data. I cannot go back and say that. I lose my business with a client. You're losing the trust and the confidence with a client. So I cannot do that. So for that reason, you need to make sure you're committing your data periodically. Okay. And you also should have a rollback to say, I don't want to save the data because if I commit, I should commit everything. If I don't commit everything, I should roll back. Don't commit part of it, leaving the rest. No, that's not what I want. Okay, that is about rollback. I think that's pretty much. I want to talk about SQL. Let me quickly take a look at your textbook. um, okay, we'll talk about all these when we talk tomorrow a little bit. Okay, I think this is where I want to stop today. Take a short break. We'll talk about this. I just got some of the queries that I want to talk about. I think we'll do that tomorrow, the next session we meet. And then with that, we should be done. I am done for today. I want to stop and pause for questions, any feedback, comments, anything that you want to talk to me within the subject, outside the subject. Like I said, tomorrow will be the last session. So if you have anything, feel free to discuss. I am happy to do that. I'm going to stop our recording for now, and I'll be here for some more time to talk. Thanks, guys. I appreciate all your time today.